Greetings and welcome once again to a very short presentation on the new Calculus channel. And I'll go through this a little slower than I did the previous two so you can understand. The Holy Grail of Calculus is my historic geometric theorem of January 2020. So this is what Newton, Leibniz, Cauchy, and everybody else was trying to figure out, but they couldn't because they weren't as smart as I am. That's all there is to it. And that's not arrogance, it's a fact. So what does the geometric theorem say? Let's look at the statement. So it says that f of x plus h minus f of x over h is equal to f prime of x plus q of x h. What that says is that the left-hand side here, which is the slope of a non-parallel secant line, is equal to the derivative plus the difference in slopes. So let's quickly run through this. This difference quotient on the left-hand side gives us f of x and q of x h. There's nothing to define there, by the way, people. And if you look at my geometric theorem, it explains all that to you, okay? It shows you how to find f prime of x and q of xh. So it's all written neatly and nicely inside here. Then the left-hand side, as I said, is the slope of a non-parallel secant line with endpoints as you see here, okay? The left-hand side is also an arithmetic mean of all the y-ordinates of f prime, not f of f prime, over the interval x, x plus h. Therefore, so is the right-hand side an arithmetic mean, right? Because why? Duh, it's equal to the left-hand side. Okay, number 4. The area is generally defined as a product of arithmetic means. That's what I discovered because, once again, I'm a genius and nobody before me knew these things, okay? And it means that so is the area of f prime under the curve given by this product, okay? By h times the arithmetic mean of all the y-ordinates. Okay, so this product here is in fact equal to the integral of f prime of x from x to x plus h. But you don't have to worry about the integration, because if you've got the primitive function and its derivative, that's all you need. So thus, from one identity, people, from one identity, we define both the derivative and the definite integral without any ill-formed concepts such as infinity, infinitesimals, and the circular rot of limit theory. And of course, we can see, no matter how we position the points, that it doesn't matter where the points are and what the functions are, this theory is true. So you'll get the correct area every time, you'll get the correct derivative and the slope difference, as well as the slope of the non-parallel secant line. Now, smart people would have noticed that this top part here is actually equal to the integral, isn't it? F of x plus h minus f of x. Well, for the last, I don't know how many 100 years, nobody realized that. And nobody could see the relationship between this, the derivative, and the slope difference, and how we can use it to find the area. Okay? So that's pretty much it. I don't want to ramble on and on. I'm going to place a link to my historic theorem, which also explains in this slide here a general proof that h is a factor of f of x plus h minus f of x. Now, some people don't know what a factor is, so look it up. It doesn't necessarily have to be an integer, by the way. It can be any magnitude or what is commonly thought of as a real number. So you can look at this, and you can see very clearly that it doesn't matter what function you have, excuse me, h will divide the left-hand side, which is f of x plus h minus f of x. And so that's pretty much it. Please subscribe to the channel, click like, spread the news, tell everybody. I'd like this channel to become the top math channel, which is where it belongs. Okay, so I've explained to you the Holy Grail of Calculus, something that Newton and Leibniz would have paid a fortune to know, because they didn't know these things, and neither did any of the morons in the mainstream who came after them. That's why they gave you that huge shit pile of limit theory and real analysis and all that other garbage, when all you really need, people, is just geometry, okay? And the identity from my historic geometric theorem. I hope you have enjoyed this. Till next time, I'm John Gabriel. Goodbye.